In this video, we're going to look at multiplying polynomials. So this kind of expands on the idea of FOIL, but now we're doing it when we can't necessarily use FOIL, but we still want to kind of use that idea to help us. All right, so FOIL only works when you have two terms multiplied by another two terms. All right, so there's two here, two here. That allows us to do FOIL, but we're still going to use this kind of principle when we're applying it to larger problems. So if we look at this first example, all right, we can't use FOIL here because there's too many terms. All right, there's three terms in this first one. There's just two terms in the second one, but we have too many. All right. But the principle of FOIL, if we look at kind of what's happening with FOIL, let's just kind of make up a random problem. All right. You do first and outer, and then inner and last. And you look at this x term goes to both of the terms in the second part. This 3 term goes to both of the terms in the second part. So really you're just doing the distributive property twice, which is in a kind of convenient way to help you memorize what's happening, which ones you've already done. All right, but we're going to use the same idea here. All right, this 1 has to go to both these terms. This plus x squared needs to go to both these terms. And this x to the 4th needs to go to both those terms. So really we're just kind of doing foiling on a larger scale, make sure every term goes to every other term. So I normally just start at the first one, 1, and I'll do 1 times 3 and 1 times negative x squared. Right. Then I won't normally do this, but just kind of show what's happening. All right, I did that one and multiplied both by 1. Now move on to x squared. X squared times 3 is 3x squared. X squared times negative x squared is negative x to the 4th. Right, and now I'm done with x squared because I've multiplied both. And now I do x to the 4th, 3x to the 4th minus x to the 6th. Right. And now I've gone through everything, sent everything in that first pair of parentheses to everything in the second. So these are all the terms I need. And then to get my final answer, I just combine like terms. All right, so I have some x squared terms and some x to the 4th terms. My final answer, 3 plus 2x squared plus 2x to the 4th minus x to the 6th. All right, so same principle of FOIL. You're kind of sending one term to everything in the next term. It's kind of the distributive property. We can still do it in kind of a shortcut way without having to write down a bunch of distribution. All right, so one more example. Again, doesn't matter how many terms there are. I'm just going to send this first term to everything in the second term, or second parentheses, and do the same thing with the second one here to everything. As long as I do all these pairs, I'll get everything I need. So it's going to be 2x minus 2x to the 4th plus 4x to the 6th. All right, so that's the 2x part, multiplying it by everything in the second. And then now I do the same thing for x squared. It's going to be x squared minus x to the 5th plus 2x to the 7th. And let's see, do we have any like terms? We have a single x. We have an x squared. 4, 5, 6, 7. Yep, no like terms at all. So this is actually just our final answer when we do all those multiplications. Again, being careful with negative signs and exponents. We get our answer when we multiply these things together. All right, so here's one for you to try on your own. I multiplied these things together. All right, and here's the final answer I got. So when we multiply this 2 by everything, we get these 3 terms. Multiply the x by everything, we get these 3 terms. And we can combine some common or some like terms. All right, so when we combine our like terms, we get these 4 terms for our final answer. Again, as long as you kind of remember to multiply everything in one by everything in the other, then you get all the terms you need. And it's combining like terms. And make sure you combine like terms for your final answer. That's something I'll be looking for on the skill checks. All right, so here's an example. Again, common mistake that people make with foiling. They'll make the same type of mistake here. All right, by just, again, the common wrong answer would be 1 minus 4x squared plus 16x to the 6th, something like that. All right, but when you just get these 3 terms, you're kind of just squaring every term, but that's not how it's going to work because this is a shortcut for multiplying something by itself. And again, when we multiply all this, we have to distribute the 1 in, distribute the minus 2x in, and distribute the 4x cubed in. So we're going to end up having these 9 different multiplications we have to do in this case. All right, but let's just go one piece at a time. So 1 times 1, 1 times minus 2x, 1 times 4x cubed. So again, that takes care of the 1 there. Then minus 2x times 1, minus 2x times minus 2x is going to be plus 4x squared. Minus 2x times 4x cubed is going to be minus 8x to the 4th. And same thing for 4x cubed. We got rid of this one now. 4x cubed is going to be 4x cubed times negative 2x is going to be negative 8x to the 4th. And then times 4x cubed. 4 times 4 is 16. And then x to the 6th. So again, we had these 9 terms because this 1's going to 3. The negative 2x is going to 3 terms. 4x cubed is going to 3 terms. And then we look for all the like terms. Let's see, we have x's. Those are all x's. We have some cubes. We have some squareds. Oh no, we only have 1 squared. But we do have some fourths. All right, so if we combine all our like terms, and just to do it this way, again, I mentioned in a different video that a lot of times you write the exponents in descending order. So I'll put this term first and kind of move these things how I want. X to the 4th would come next. Now there's negative 16 of those. X cubes would be next. Then x squared, we only have 1 x squared term. Then the single x terms. And then the constant term, 1. All right, so this is the way you probably see the final answer in a textbook or something like that, because the exponents are getting smaller as you go down. There's nothing wrong about writing the other way, but just kind of to show you again how you might see it in different formats. All right, so here's one for you to try on your own. All right, really similar to the last example. And here's the answer I got. Again, I wrote it in a specific order where the exponent is getting smaller, but as long as you have all the same terms, your answer is right. So, all right, this 1, again, we're doing a squared, so you can rewrite it as this thing multiplied by itself. I would distribute the 1 in to get these first 3 terms, distribute the minus x in to get the next 3 terms, distribute the x squared in to get the next 3 terms. All right, so, and then combining all the like terms gets us down here to our final answer. All right, so go ahead and practice this skill. Again, one of those things that as you're practicing this skill, you can probably get pretty good at it, but the bigger thing is remembering as we go on through the year, whenever you have multiple things being multiplied by multiple things, I just remember to kind of distribute things in to the other parentheses.